The following problem states, in which process does the nitrogen undergo oxidation? Well, when we're dealing with oxidation, we know we have two acronyms that we can use. We can use G and Leo, which G is the gaining of electrons is reduction, and the loss of electrons is oxidation. So in this case, we are using Leo, and we're looking in each of these different problems, which of the following is the nitrogen undergoing oxidation? So we're looking for where does the nitrogen lose electrons in the following scenarios. So let's start off with A. And when we do these problems, remember you have to take in consideration the rules for determining oxidation numbers. So in this case, when nitrogen is in its elemental form and nitrogen is diatomic, it's always 0. And so we're going from nitrogen at 0 to nitrogen and NH3, where we know hydrogen is always +1, and we don't know exactly in this case what nitrogen is, so we can set up the following algebraic expression that we don't know the oxidation number for nitrogen, plus we know the oxidation number for hydrogen, which is 1, and this is a neutral molecule, so it's all equal to 0. And we can solve for x to be -3. So in this case, nitrogen is going from 0 to -3 for the oxidation number, so it's not undergoing oxidation, it's going under reduction. Remember, the more negative it is, that means it's gained electrons. The more positive it is, that means it's lost electrons. So let's do B. So we have N2O4. In this case, the oxidation number of oxygen is going to take precedence over that of nitrogen, so it's going to be -2. And so we don't know the oxidation number of nitrogen, so we're going to put x, because we're solving for it, plus 4 times -2. It's a neutral molecule, so 0. So 2x minus 8 is equal to 0, and so x ends up equaling 4. Let's do the same thing for that of the reactants for NO2. So in this case, it would be x plus 2 times -2 is equal to 0, and x will be equal to 4. We have no change in the oxidation state of nitrogen, so this is also not undergoing oxidation. For C, let's set it up in a similar manner. We don't know the oxidation number of nitrogen, but we know that of oxygen, which is -2. This is equal to 0. So x minus 6 is equal to 0, so x is equal to +6 for that nitrogen. Let's do the same thing for the products. So we don't know the oxidation number of nitrogen, plus we know the oxidation number of oxygen, and this is equal to 0. So we have 2x minus 10 is equal to 0, and we end up getting x is equal to 5. So in this case, my nitrogen is becoming more negative, so it's undergoing reduction, not oxidation. So lastly, for D, in this case, these are charged species, so we have to set that equal to that charged species. So we don't know the oxidation state of nitrogen, but we know that of oxygen, and this is equal to -1. So we have x minus 4 is equal to -1. We add 4 to both sides, and so we get x is equal to 3. And for the product side, we have x plus 3 times -2 is equal to -1. X minus 6 is equal to -1. We add 6 to both sides, and we get x is equal to 5. In this case, we have x, the oxidation number for nitrogen is going from 3 to 5, so it's getting more positive, so it's losing electrons, so it's undergoing oxidation. So the correct answer would be D. It's important when you go through these types of problem, you remember the how to solve for oxidation numbers and the rules associated to them as well. And then you're looking, in this case, for oxidation. So you're looking for where the nitrogen loses electrons. So the oxidation number increases. So So in the case of D, it goes from 3 to 5. Thank you.